All right, hey everybody. This video is to help you prepare for your Unit 3 quiz. So I went through your quiz and I made a checklist of everything you need to be able to do. So you need to be able to determine domain, use laws of exponents. One thing that I didn't cover a super lot in my last video is rational exponents, so that's what this will mostly be on, and then just finding roots. So let's start with the determining domain though. So let's say it asks you to find the domain of f of x equals the square root of 5x plus 35. So you ask yourself, what is the smallest or biggest thing that could work in this function? So the smallest thing I can take a square root of is 0. The biggest thing is infinity. Could keep going forever. So then I ask, what could I plug in here to get out of 0? Or in other words, 5x plus 35 equals 0, and solve that. So subtract 35 from both sides, and divide by 5 on both sides. And I get x equals -7. Now for this one, over here, I can go all the way up to infinity. So my solution set there would look like x such that I said more than -7 all the way up to infinity. So it'd be x is, oops, wrong sign, greater than or equal to -7. And that's how you determine your domain. What's the smallest and biggest thing it could be, and then just write it in your set notation. Okay, so that one's done. We're going to come back to laws of exponents. Let's jump down to roots here. So when you're determining roots, the big thing to watch out for is the principal and negative square roots. So if I take the square root of 36, the principal square root would be 6, and the negative square root would be -6. That was really terrible handwriting, but hopefully you can listen along. I made a whole video about this last week. You can check that out a little bit more. This is just supposed to be a quick recap. A reminder that the square root of -36, though, would not be real. Its principal square root would be 6i, and its negative square root would be -6i. That is not true for cubes, though. For a cube, you can take a negative, because -3 cubed would be a -27. And those ones only have one root, if it has an odd index up there. Okay, so that's roots. Next thing is laws of exponents, which let's look at. Let me find a good example here instead of just trying to make one up. Let's say that we had x to the -3rd, y to the 4th, z to the 5th, all squared, times y to the -8th, z. Okay, so following order of operations, parentheses, can't do anything inside the parentheses, exponents. I have a power to a power right here, so those all get multiplied to that power, and I get x to the -6, y to the 8th, z to the 10th, and then y to the -8th, z. Okay, can't do any more with the exponents. Multiply. You just multiply the matching parts. I have x to the -6, -8, y to the 8 times y to the -8th. You add the exponents, 8 plus -8 is 0. Same thing with the z's. 10 plus 1 is 11. Okay, and then we're almost done, but we need to simplify. Negative in the exponent is a no-no, so that's got to come down to the denominator. Y to the 0th is 1 times z to the 11th is z to the 11th. So that right there would be your most simplified form. Okay, so that is, wrong button, that is the laws of exponents, mostly. There's another video posted last week if you're still not sure on those. And then last but certainly not least, we have rational exponents here. So rational exponents I didn't cover a ton of in the last video. I'll be honest, I forgot. So in a rational exponent, let's say x to the 2/3, the way I remember it is you have the power over the root. Another way you could think of it is in a tree, the root is on the bottom, and then your exponent is there. So x to the 2/3 could be rewritten as the cubed root of x squared. You have the power right there over the root down there. So where this becomes helpful is, let's say we had something like let's see, I had an example. I can't find my example. I'll make something up. Let's say we had the cube root of x to the 9th y to the 4th. You could probably see that the cube root of 9 x to the 9th would be x to the 3rd, but if we rewrite that with roots, this could be rewritten as x to the 9th, y to the 4th, all to the 1/3, which is x to the 9/3, y to the 4/3, which then I can see simplifies to 9 divided by 3 is 3, so x to the 3rd, y to the 4/3, which then tells me the most simplified form of this, moving it back to radical form, is x to the 3rd, and then I have to power over the root with the y there. Okay, so let's try an extreme one, and then we'll come back from there. So let's say we have the 5th root of 2x to the 8th y, all taken to the 9th. So first thing I would do is take care of this radical here and change that to 2 to the 1/5, x to the 8/5, and y to the 1/5, all to the 9th. Then I can bring that 9 in and go 2 to the 9/5, x to the 72/5, y to the 9/5. And then start simplifying those. So 9 divided by 5 is 1 with 4/5 left over. So I would have 2 to the 1st, and then I'm going to leave a little space and go like this. And you'll see why here in a sec. 72 divided by 5 is 14. Yeah. With 2 left over. So I'll put that 2 there with a 5 underneath. And then y, I'll have 1y with 4 of them left over, just like the 2. Okay, so then when I go back to go into radical form again, let's see. Oops. I'll write it up here. We'll go up here. When I go back to write it in radical form, I have a 2 outside, an x to the 14th outside, a y outside, and then if you notice on my root, the bottom number is the same on all of them. So I can put them all under one big root. I have 2 to the 4th there, x squared there, y to the 4th there. And then last but not least, I can take that 2 to the 4th and get 2x to the 14th, y to the 1st, and then the 5th root of 2 to the 4th is 2, 4, 8, 16, x squared, y to the 4th. Okay, now that may not look easier than just doing it outright, and if it's not for you, that's fine. Don't worry about changing it to fractions and then back to not fractions and all that. However you can get there is fine. That the rational roots there, or fractional roots, just kind of help you out with that as another strategy. So that's the last thing. If you can do all of these things, you are ready for your quiz. If you are still having questions about any of them, send me an email or check out last week for videos on determining domain and finding those roots and finding those laws of exponents. Okay, good luck.